And we're live. Wonderful. Hello, everyone. Happy Thursday and welcome to our webinar for today. It is the top of the hour, so we are going to go ahead and get right started. My name is Heather Grant. I'm one of the community admins at the maintenance community by Upkeep. Thank you, everyone, for joining us today. If you are not already a member of the maintenance community on Slack, we would love to have you join us. We will add the link in the chat on how to sign up shortly. Today we have with us Michael Bernhard. Michael is going to be running us through a presentation called Powering Predictive Maintenance. I'm very excited, Michael. Thank you so much for joining us.
I appreciate the invite. I'm excited to hopefully give some quality information to everybody and help them along their journey.
Awesome. A couple pieces of housekeeping before we get into the presentation. The recording from today's session as well as the slides will be shared this afternoon in the maintenance community on Slack. Michael is also available and active in the Slack, so he can answer any and all follow-up questions that you may have afterwards. Michael and I will be the only ones with our video and audio on today, so if you have any questions during the presentation, or if you want to answer any questions that are posed to you, please use the chat feature and the questions feature over on the right-hand side of your screen. Let me know if there's any technical issues or anything like that going on as well. I will be watching the questions as they come in throughout the presentation, and then we will have some time set aside at the end to go through and answer them. So that's all from me. Thank you again, everyone, for joining. And Michael, I'll turn it over to you.
Awesome. Well, let me try to share my screen so we can get everybody started. I know we have an hour set aside, but I'm going to give you a lot of time back left in your day, hopefully. So we'll try this again. It worked the first time. All right. Well, I appreciate everybody joining today. Today's goal is just to kind of give you some really practical 4 steps on how to deploy a condition monitoring or predictive maintenance solution successfully and with as little headache as possible. A little bit of background about me. So I'm a senior solution architect at Nikola Labs. My biggest responsibility is to guide our customer base on how to do exactly what we're going to walk through today, and then help them pilot programs and then scale successfully, so they're able to get a return on investment and see the upside in the promise of predictive maintenance. My background, I was in the United States Coast Guard directly out of high school, majored in business management, had an athletic career directly after my military service, and then found myself back in Ohio and started working for Nikola Labs. Nikola Labs commercialized some technology out of Ohio State University about 6.5 years ago around ultra-low power electronic design and some other technologies, and then we deployed that into some technology that we hold for our personal solution. So today we're just going to talk about the obvious problem around manufacturing and unplanned downtime, what the solution looks like, what the promise behind the solution is, and then what the current reality holds for most of you in the reliability field. And then we'll go over some practical steps to bridge the gap between where you're at now to where you want to be, in the next 4, 6, 12 months from now. So biggest problem for manufacturers currently, and where they're losing, really billions of dollars per year, is unplanned outages. Unplanned downtime is measured, differently at different facilities, but a large chunk of companies are completely unaware of the financial implications of major breakdowns due to equipment failures and loss of production time. So there's still a huge prevalence of more than half of companies still use the run to failure break fix model when it comes to maintenance. Scheduled maintenance or planned maintenance is a huge improvement, but it still has some gaps and can cause some excess, manpower when you talk about loss of, a smaller labor pool. And then, also reactive maintenance tends to be quite a bit more expensive than proactive maintenance, as most of you know, as you're experts in this field. And as you get into more lean manufacturing, the cost of downtime is increasing significantly, especially over the past 3 years in really all major industries, because we don't have warehouses full of product sitting to go out the door. Pretty much everything is off the line in a truck and to your customers. So unplanned outages can be catastrophic. Things are getting better when it comes to the world of maintenance reliability. You have groups that that we're part of here, and run to failure has dropped significantly. At least a few percentage points over the last 10 years. Predictive maintenance is already used in the majority of manufacturers and public utility companies, and it's going to increase over the next 2+ years to over 80% should be using predictive maintenance or condition monitoring. So really, if you think about it, ask yourself, where are you guys at in your journey? Some stats that come out each year from U.S. Department of Energy and also publications from like PricewaterhouseCoopers kind of give a really good financial implications of utilizing predictive maintenance, right? And we'll talk about this step by step. A well-orchestrated predictive maintenance program can basically eliminate catastrophic equipment failure. If you're able to do that, typically you can look for up to a 10x return on investment. You can reduce your maintenance costs, by 25-30%, and a reduction in downtime as a whole at 35-45%, and then overall increase in production. So powering really your uptime by reducing the downtime. So really the main part of today is how to bridge the gap from where you are today to where you want to be in the future, and do this with as few headaches as possible. So I specialize in helping plan this with customers. Today is not a sales pitch. Today is just information for you of my thought process on the best way to implement this in your facility and in your organization. So really step one is design and implement a pilot, right? So figure out, a number of assets that you would want to monitor with different companies. So through that, I think the biggest thing you can talk about is looking at rotating equipment and focus on vibration. That's going to be the easiest to implement. It's going to give you a lot of options when you think of the marketplace. And it's also easy to track along the way. You want to really create a list of criticality, when you look at your equipment, right? So stationary rotating equipment, most of you are, probably off the top of your head could name a ton of this stuff. How I look at it along the way with the companies that I talk to is we look at aging equipment. A lot of those parts either might be, have a long lead time to get replacement parts. Assets that are hard to access, you think of like rooftop blowers that if it does cause an outage, you might have to have a crane come in and cause a lot of issues. High value assets, right? There's motor gearbox combos that are $250,000 at some facilities. And then just historically bad actors, things where you've seen previous faults, right? So go through your criticality list and start targeting some of those assets. And then for your pilot, look at a multitude of equipment, from utilities to production, to really get a good sample of data when you launch your pilot. When you're launching a pilot, you want to kind of keep your costs low up front. So wired sensors are probably going to be your most expensive CapEx option. They're highly reliable, but it's very expensive to do. You want to try to make sure that the installation is simple. You don't want to spend a ton of time on your pilot. So wireless sensors are going to be the easiest to deploy. And that also gives you some flexibility. So when the pilot is done, once it's over, you can remove them easily. You can move them to different assets. If you find that the value wasn't on that asset that you had picked, maybe it wasn't the right right piece of equipment or something along those lines. When your pilot's over, you can change those. And then you want to also focus on your battery, the battery life of it. Let's say you're going with wireless, understand the warranties behind it, the maintenance responsibilities behind it, and what that estimated battery life is. So just compare and contrast with the companies that you're looking at. And another really important thing, not all wireless sensors are created equal. So ensure that you're getting the best data possible. So you want to look for typically triaxial and something that's going to give you the ability to see the full spectrum data rather than just trend data. Is going to be what I feel like is going to be highly important around being able to successfully deploy this. So really, from there, you want to, during your pilot, you've got really 3 things that you're going to focus on: monitoring, analyze, and optimize the program as you go. So one thing that you'll probably run into a lot is going to be cloud-based software. Today, this is just where the data is going, right? So there's some companies that they don't want to embrace the cloud, but I do think this is the easiest way to deploy this. So you want to look for a dashboard and reporting, things that you can customize to your specifications and gives you the ability to see your facility from a high level all the way down to a micro level. Look for, as I touched in the first part, high resolution data. You will want to be able to see your trend data. So if you're not a vibration analyst, it's easy to understand that, up is bad, flat is typically okay. And it's also going to give you a multitude of information from your peak vibration on all 3 axes. Also, monitors temperature as well. There's other solutions that might monitor amperage or runtime, things like that. And then, like I said, I think it's important that you select a piece of equipment that's going to give you in-depth data and allows you to see your FFTs and your time waveforms, especially if you're relying on vibration and you want to be able to remotely analyze the data. So the other thing that you'll want to look into is the type of feedback that those sensors are giving you, right? So some sensors are just going to give you threshold alerts. There's other solutions that basically are strictly AI, so they're going to give you a general analysis of what they're reading, but it typically is a list. And then you have solutions that are a blend of AI and human monitored, and then you just have the ability to monitor internally as well. So you want to be sure that you're getting some sort of feedback from that sensor, and it's not just squiggly lines on the screen. So you want to look for things that are prescriptive assets, and they're giving you technical recommendations, so you can take action on those alerts rather than just receive alerts from the sensor, and you'll end up getting a lot of email fatigue. So during the pilot, you just want to conduct ongoing analysis. You want to make sure that you're continuing to get high quality data. You want to work to understand the operations of your equipment and that it's giving you that feedback. And then really during the pilot, focus on it daily. Take some time to look at it daily, and so you can really start to understand each system that you're looking into. And then as you come up with issues, collaborate with the rest of your team until those issues are resolved, and then go back and compare the data once those repairs are made. This portion of that is really important. If you don't have in-house vibration experts, you can utilize a third party to analyze the data as well and give you that feedback. Really, so step 3 is act and validate. When we look at this, we want to find out if there was early detection during the pilot. So what did you find by deploying these pilots? From that point, right, it's great if you find issues, but think about your facility or your organization's ability to react to that information. So what did you do with the information? If you're able to detect it early, but you didn't have time to get to it because you had other things, other fires you're putting out, take note to that, because it might let you know where you're at and how fast you should deploy this. Because the last thing you want to do is spend a lot of money and then not use it efficiently. If you're able to find it and act on it, at that point you want to figure out what you saved by doing that. So as you go to the powers that be that are going to approve this type of expenditure, you can show them what you saved. So, detection plus action equals fewer unplanned events and increased uptime, which ultimately decreases facility asset maintenance cost. And that is our number one goal when deploying a condition-based monitoring or predictive maintenance solution in a facility. So a big part of that is understanding the cost to your company. So understanding all of your maintenance labor costs, understanding your repair replacement costs, and then understanding what downtime hours are for a piece of equipment. If it's in a piece of equipment that shuts down the whole facility, then I'm sure it's extremely high. And also understanding a piece of equipment that might just shut down a part of a line or a line in general. Being able to put that into dollars and cents will enable you to count sort of the hours and maintenance costs behind that. And there's tools out there I'm sure you can find to help you calculate that, and then also just working with your team to understand the value so you can see your ROI, and your goal is to find that 10x experience. Once you find that 10x experience, you prove that to the powers that be upstream. You want to think about the ability to scale, right? So there's a saying, you don't eat an elephant in one bite, you eat in a bunch of small bites. So being able to scale at a pace that's going to keep you productive and then also enable you to respond. Because if you go from 0 to 100, you might start getting alerts and recommendations you can't keep up with. So you want to scale accordingly. A big part of that is the system that you select, does it have the ability to integrate, right? So there's systems out there that can integrate with your CMMS system that will generate work orders automatically when a recommendation comes through. That can help avoid double data entry and allow things to get done in the proper time period. And as you're scaling, you want to right size the program. So looking at, do you have time to order sensors and install them yourself? Do you have that bandwidth, or can you look for somebody that does the installation for you? You want to look at the reliability and maintenance of the equipment. Do you own that responsibility, or does someone else own it? If you have batteries to replace, what's the life expectancy? Is that a maximum time frame, or is that if it doesn't ever hit an alert mode? Does it come with any vibration analysis tools? Like I said, look at the warranties and upgrade options, especially if you're spending a lot of money on the sensors. What does it look like if they come out with a new sensor? Does it offer multi-site enterprise discounts? These would be more for regional directors, or if you have connections to other facilities, does it make sense to deploy it in other facilities so you save money? And then you'll have to measure out CapEx expenditure, or there are subscription pricing to where it's more of an operational expense. Which one is easier to get approved? A lot of these things are going to be really important when you're deciding. I think it's important when you're running the pilot to compare 2 or 3, and I always recommend doing it at the same time, right? It's going to allow you to cut your pilot times down, so you're not spending a year on your pilot. You could put 2 or 3 systems side by side, similar equipment, and compare and contrast the likes, dislikes, costs, and then avoidance around the same thing. And really, if you think about the world of IoT and the infrastructure, it can take. So as we know that the labor pool is smaller. There's a loss of tribal knowledge when it comes to. There's a lot more people retiring than there's entering the workforce. And utilizing technology, I don't think it's ever going to replace humans, but it can give a smaller amount of humans the ability to manage much more equipment and make them much more productive as they go. And really, from there, that is it. So that's really my step-by-step guide of how to deploy a really powerful predictive maintenance solution with as little headache as possible. I'd like to spend the next, however long answering questions that you all might have. I've got the time, so that's what I have. So
Wonderful. Thank you so much, Michael, for presenting with us today. If you do have any questions, please feel free to send them through in the chat. We haven't actually had any come through, meaning I'm assuming your information was bite-sized and helpful and very specific for all of our attendees. I have one question that perhaps ties back into some things you said during the presentation, but what is one of the most common mistakes you see people making when they, embark on a predictive maintenance journey?
So a lot of times it's lack of data. So they'll think about a pilot and they'll think of it in too small of a scale. So they might only want to deploy a handful of sensors, right? So a handful of sensors is going to give you information on one, maybe two pieces of equipment. So understanding that, if you're casting a pilot and you have options behind it, it's okay to, you don't have to obviously go crazy with it, but when you're testing something, give a large net so you're able to get more data, get more information. It's always easier to scale back than it is to scale up most of the time. So the number one, that's probably the biggest mistake that I see is people wanting to do very small trials or pilots, as we call them.
Awesome. And then I have a follow-up question too. When people are getting started, after they've kind of started with one type of sensor or one type of technology, is it then pretty easy to kind of expand to other technologies, or is it like a whole new kind of beast each time?
Well, that really depends on the platform that you use. So the great thing about where we're at when it comes to IoT, most systems will be friendly with each other. Like I'm sure that Upkeep has the ability to communicate with other systems and APIs that are built. I know that our interface is open and we have the ability to communicate. So once you have a foundation laid, at that point it's just finding the right the other solutions that are going to work nicely together. And where IoT is going, especially in the world of sensors, it's really easy to find things that are collaborative. And then there's also companies that have multiple types of monitoring available to them. So that's another thing to consider when you're building. Where are they at? Where are they going? And then what communicates well.
Is it common for people to find kind of all-in-one solutions, meaning like the same provider can fit all of their needs, or is it more common that they'll have to find different systems that communicate?
So the thing that I've seen in conversation I have every day is I think everybody's looking for the golden goose, like the thing that fits everything, and it just doesn't exist, not yet. There's things that come close, but it just doesn't exist. Now I don't think remote sensors are going to be to cover 100% of your equipment because you're never going to get a return on your investment. So finding the right blend of technology with boots on the ground is really key. It's really hard to find a one size fits all because as far as I know, it doesn't exist. You can see who can offer a blend of solutions or collaborate with other other technologies is really where you're going to be able to find it. But that is something that I don't think exists right now, is a one size fixes all.
Yeah, I understand what you're saying about the golden goose, finding that ideal solution is, and no matter kind of what you're trying to solve for, whether it's sensors for a remote maintenance project or software for another kind of business need. I don't know if there's ever the perfect for every single use case. I have one more question. I see we have a person typing here with a question. Who is the person within an organization who typically kind of leads this charge or is responsible for starting up a program like this? Is it the maintenance manager? Is it somebody on the reliability side?
So honestly, it's all over the board. I've started conversations with maintenance technicians who then take it to their maintenance supervisor or maintenance manager. Obviously, reliability engineers are really involved, and then you have, but typically the deciding factor is going to be your maintenance manager, and then obviously approval through plant managers. But I think if you could see, if you're in a position to say you're just a maintenance technician and you see there could be improvements, right? Like it's okay to like step your foot forward and like recommend something, especially if it's pretty low risk. But I really think, the maintenance managers, engineering managers are another one, are going to be the ones that typically drive this. And if they're driving it, they're the experts in their reliability department. So it tends to make it easier if they're on board.
Yeah, I can see that. Cool. Well, those are the few questions I had in my head after the presentation. We haven't gotten any more through today. So I think we can leave it there. Again, the recording of today's session as well as the slides and Michael himself are all available in the Slack community. If you do have any questions, either on a one-to-one basis, feel free to kind of reach out there. I am seeing someone typing now again, so I will continue to say goodbye in a longer way in case they can get a question fired off. But if not, thank you again, Michael, for taking the time. We really appreciate having you here, and I will see everyone next time.
All right. Thank you so much, Heather. I appreciate it. If anyone has questions, like I said, reach out to me. I'm pretty active on the Slack channel, so you can either direct message me or include me in a comment.
Yeah, and contact information is at the end of the slides as well. So feel free to get in touch if you do have any questions. And thank you again.
All right. Thank you.
Thank you. Bye, everyone.